Okay, so non-blocking channel operations. Basic sends and receives on channels are blocking. However, we can use select with the default clause to implement non-blocking sends. Yeah, right. Receives and even non-blocking multi-way selects. Non-blocking multi-way selects, interesting. Okay, here's a non-blocking receive. If a value is available on message, then select will take the message case with that value. If not, it will immediately take the default case. Okay. Okay. Message received. No message received. Wait. Because there is nothing in channel, right? A non-blocking send works similarly. Here is message cannot be sent to the message channel because the channel has no buffer and there is no receiver. Therefore, the default case is selected. Message hi. Send to message. Yeah, because there is no receiver, so it blocks and it just skips it to the next one. You can use multiple case above the default clause to implement a multi-way non-blocking select. Here we attempt non-blocking receives on both messages and signals. So it won't trigger because there is no receiver and it's not gonna work here anymore. Makes sense. Okay, what's next? Closing channels. Closing channel indicates that no more value will be sent on it. This can be useful to communicate completion to the channel's receivers. In this example, we'll use a jobs channel to communicate work to be done from the main routine to a work routine. When we have no more jobs for the worker, we'll close the jobs channel. Interesting. So let me see, it's like channel of ints is len of 5. Done. Go routine. What we do? We take an int and if it closes or not. Done, sure, return the end. This is hard to reason about. Okay, so that works. And we immediately go here. It triggers like 3 times. And sends 1, 2, 3 to jobs. Nice, yeah, and then it closes it. Yeah. And then but if it is buffered, can't we just close it before we read everything? Like send job received, send received, send received. But what if we have not received the last one, but it already closed? Interesting. Done. So we're waiting until it's done. Yeah, okay, wait, no. More. I guess it must be somehow baked in, right? So it won't be close until we read everything. Depends on the problem, but generally speaking, I would tend to say no, you don't need to clear the channel before closing it. If there are items in your channel when you close it, any reader still reading from the channel will see the items until the channel is empty. Okay. But Will the value preserve chromo output items despite the fact that channel is closed strictly before any reader can even read from the channel? The better is to achieve what you're trying to achieve, you can't produce it. What you want is not what I want. Range and close. There's no saying about, or is there? A sender can close a channel to indicate that no more values will be sent. Receivers can test whether a channel has been closed by assigning a second parameter to the receive expression after. Okay, solves if there is no more values to receive, the channel is closed, right? But what if it's buffered? Okay, I guess I'll understand it in practice. And then we are waiting until routine is done. After that, we are waiting for jobs to be done, but isn't it like already closed? More interesting. Okay, let's read. Here's a worker routine. It repeatedly receives from jobs with J more jobs in the special second value form of receive. The more value will be. Okay, let's read. In the special second value form of receive, the more value will be false if jobs has been closed and all values in the channel have been already received. Okay, so and all values have been already received. We use this to notify on done when we have worked all our jobs. Yep. This sends 3 jobs to the worker over the jobs channel, then closes it. We await the worker using synchronization approach. We saw earlier, yeah. Reading from closed channel succeeds immediately, returning the 0 value of underlying type. The optional second return value is true if the value received was delivered by a successful send operation to the channel. Or false if it was 0 value generated because the channel is closed empty. Yeah, right, so it's just for the sake of demonstration here, right? Okay. Range over channels. In the previous example, we saw how for and range provide iteration over basic data structures. We can also use this syntax to iterate over values received from channel. We'll iterate over 2 values in the queue channel. Queue. Okay, 1, 2, close queue. And so, because it's buffered and we haven't read all the values, it's not gonna be closed immediately, right? Then we arrange through all of them and print them, yeah. The range iterates over each element as it's received from the queue. Because we close the channel above, the iteration terminates after receiving the second element. Okay, because we close the channel above, the iteration terminates after receiving second element. Okay, so range automatically checks if the second value is false. So we don't need to do that. Yeah, that's cool. That's cool. This example also shows that it's possible to close a non-empty channel but still have the remaining values be received. Yep. Yep. Next example, timers. Yeah, I guess it's not concurrency anymore, right? Or is it? Tickers, I guess it's concurrency. Yeah. We often want to execute Go code at some point in the future or repeatedly at some interval. Okay, Go's built-in timer and ticker features make both of these tasks easier. We'll look first at timers and then at tickers. Okay. Timers represent a single event in the future. You tell the timer how long you want to wait, and it provides a channel that will be notified at that time. The timer will wait 2 seconds. Interesting. So it's a channel which will receive value only after 2 seconds, right? And we are waiting. Why it prints after? Because it's fired. No, wait, fired means it started, right? Timer 1 C. What is C? Okay, blocks on the timer's channel C until it sends a value indicating that timer is fired. Timer fired, yeah. If you just want to wait, you could have used time sleep. One reason a timer may be useful is that you can cancel the timer before it fires. Here's an example of that. Okay, we're creating a timer, launching a routine. Yeah, then we can stop it. Okay. Yep. Given the timer to enough time to fire, if it ever was going to show in the fog stopped. Okay, give the timer to enough time to fire. If it ever was going to show, it is in fact stopped. Yeah. The first timer will fire 2 seconds after. Yeah. Okay, tickers. Timers are for when you want to do something once in the future. Tickers are for when you want to do something repeatedly at regular intervals. Here's an example of a ticker that ticks periodically until we stop it. Ticker, time, new ticker. Interesting. Okay. Tickers is similar mechanism to timers, a channel that is sent values. Here we'll use the select built-in on the channel to await the values as they arrive every half a second. Okay, so we have routine, loop, select. In case it's done, we just exit in the routine, and if it's not done, we are waiting for ticker, and it prints every half a second. Nice. Nice motivations. Nice. Ticker can be stopped like timers. Once ticker is stopped, it won't receive any more values on its channel. It will stop hours after 1600 milliseconds. Stop. Done, sure. And it's gonna exit it. Ticker stopped, yeah. Nice. Looks cool. In this example, we'll look at how to implement a worker pool using a rotation channel. Okay, that one seems useful. Here's a worker of which will run several concurrent instances. These workers will receive work on the jobs channel and send the corresponding results on results. Yeah. We'll sleep a second per job to simulate an expensive task. Okay. So it has ID. Interesting. Jobs. Results. Only read and only write. We are iterating over jobs. Yeah. Login that it started job, sleeping, finish job, and we're resulting just an index of a job multiplied by 2. In order to use pool of workers, we need to send them work and collect their results. We make 2 channels for this. Number of jobs 5, yeah, jobs, results. But can we use not buffer channels? In order to use our pool of workers, we need to set them to work and collect their results. We make 2 channels for this. Okay. This starts up 3 workers initially blocked because there are no jobs yet. Makes sense? Here we send 5 jobs and then close the channel to indicate that all the work we have. That's all the work we have. So just send in a number. Okay, but what about ID? Oh, it's just. But what's the point of ID? Why would I need it? It's like really weird. Okay, so do we use this ID? Okay, we're using it's just for login. Worker 1, worker 2, yeah. Here we send 5 jobs and close the channel to indicate that all the work we have. Yeah. Close. Finally, we collect all the results of the work. This also ensures that all the worker routines have finished. An alternative way to wait for multiple routines is to use a wait group. Finally, collect all the results of the work. Yeah, so it blocks the loop until we receive another value. Yeah, so they start simultaneously, finish, and takes new task immediately. Job 4. Yeah, that's cool. And it's 2 seconds, right? For a 5-second job. Nice. Yeah, because there are 3 workers, so they do it for 1 second, and then 2 workers do another 2 jobs for 1 second. Wait groups. To wait for multiple routines to finish, we can use wait group. This is the function we'll run in every routine. Sleep to simulate an expensive task. Worker, write ID, login, sleep, login. This wait group is used to wait for all the routines launched here to finish. Not if wait group is explicitly passed into functions, it should be done by pointer. Okay. Yeah. Launch several routines and increment the wait group counter for each. I guess it's better than passing wait group inside the function and count it inside, right? Okay, wrap the worker call in a closure that makes sure to tell the wait group that this worker is done. Defer, VG done. Worker. Interesting. Okay, now now it seems like moving VG add and VG done into the function itself would be cleaner, because you will not need this anonymous function. But whatever, of the currency, primitives involves the execution. This way the worker itself doesn't have to be aware of the concurrency primitives involved in execution. Yeah, okay, that's a plus actually. You can use a non-concurrent function to execute concurrent work. Yeah. Block until the wait group counter goes back to 0. All the workers notified they're done. Yep. Note that this approach has no straightforward way to propagate errors from workers. Oh. For more advanced use cases, consider using error group package. Wow. Package error group provides synchronization, error propagation, and wow. That's it. So I'll need to separately check it, right? And it probably should return a group, which I'll check on only after that. Okay, the order of workers starting up and finishing is likely to be different for each invocation. Rate limiting. Rate limiting is an important mechanism for controlling resource utilization and maintaining quality of service. Go elegantly supports rate limiting with coroutines, channels, and tickers. First we'll look at basic rate limiting. Suppose we want to limit our handling for incoming requests. We'll serve this request of channel of the same name. So we have requests, just a channel with a line of 5, a for loop that will execute 5 times, and it just fills a channel with numbers from 1 to 5 and closes the channel immediately. Okay. This limiter channel will receive a value every 200 milliseconds. This is a regulator in our rate limiting scheme. By blocking on a receive from the limiter channel before serving each request, we limit ourselves to 1 request every 200 milliseconds. So let's see. We are going through requests. We are blocking on limiter, so until we receive channel, it's not gonna go further. And only then we are logging that we get the request. We may want to allow sharp bursts of requests in our rate limiting scheme while preserving the overall rate limit. Yeah, we can accomplish this by buffering our limiter channel. That's interesting. Time. This burst limiter channel will allow bursts for up to 3 events. Wow, that's cool. Fill up the channel to represent allowed bursting. Yeah. Wait, but why is it time now? Oh, because we'll compare it later, right? Every 200 seconds we'll try to add new value to burst the limiter up to limits of 3. But why? Wait. So it will work only once, isn't it? Every 200 seconds we'll try to add new value to burst the limiter up to its limit of 3. Yeah. So we're just adding, yeah. Burst request. We're just filling it. Closing. Then for going through burst requests, waiting for limiter, the same as in the previous example, and executing. Okay, but I still don't get it. Okay, it's 200 milliseconds. But this one, it will not... It will trigger only once, isn't it? Why would you need it? That's kind of weird. Right, our program with the first batch of requests handled once every 200 milliseconds as desired. For the second batch of requests, we serve the first 3 immediately because of the burstable rate limiting, then serve the remaining 2 with 200 millisecond delays each. Yeah, but what if we want to reload the burst? What if I want another burst here? Okay, atomic counters. The primary mechanism for managing state in Go is communication over channels. We saw this, for example, with worker pools. There are a few other options for managing state though. Here we look at using the sync atomic package for atomic counters accessed by multiple coroutines. Yeah, so we can make fast arithmetic, right? We'll use an atomic integer type to represent our always positive counter. A wait group will help us wait for coroutines to finish their work. We'll start 50 coroutines that each increments the counter exactly 1000 times. A50, VG add, launching coroutine. Ops add Jidan. So it basically just a wrapper of mutex, isn't it? Or no, it probably uses some assembly instruction, right? To make it faster. So I say no. Wait until goroutines are done. Yeah, here now goroutines are waiting to ops, but using load. But using load, it's safe to automatically read a value even while other goroutines are automatically updating it. Here now goroutines are waiting to ops, but using load, it's safe to automatically read value even while other goroutines are automatically updating it. Okay, interesting. We expect to get exactly 5000 operations. We have had we used a non-atomic integer and incremented it with ops++, we'd likely get a different number, changing between runs because the goroutines would interfere with each other, yeah. Right, so it won't always, like if two goroutines want to update it simultaneously, it will increase only by 1. Moreover, we'd get data race failures when running with a race flag. Yeah. Next we'll look at mutexes, another tool for managing state. Let's go. For complex state, we can use mutex to safely access data across multiple goroutines. Container holds a map of counters, string int. Since we want to update it concurrently for multiple goroutines, we add a mutex to synchronize access. Note that mutexes must not be copied. So if the struct is passed around, it should be down by pointer, yeah. It's actually a really easy way to fuck up. Like, you can just forget to pass it by pointer, that's it. Lock the mutex before accessing counters, unlock it at the end of the function using the first statement. Couldn't they make it just pointer by default? That would be like obvious, isn't it? To solve it. Okay, let's again. Lock the mutex before accessing counters. Unlock it at the end of the function using the first statement. Yeah, lock, unlock, yeah. Name, inc, yeah. Now the zero value of a mutex is usable as is, so no initialization is required here. New container, and we just ignore mutex. We can basically make it private, or can we? Yeah, if we are using it only with methods, we can make it private. Wait group, do increment. Okay, do increment is a function. Function definition, which takes string and int. We're going through each int, right? We just incremented for several times here. So we increment a 1,000 times, 10,000 times, then again, and then b 10,000 times. Yeah, that's cool. Run several routines concurrently, not that they all access the same container, and two of them access the same counter. Yep. I wonder why with group add is only here and not here. Oh, because it's just a definition. Yeah, we don't run them. Wait for the routines to finish. Yep. Running the program shows that counters updated as expected. Next, we'll look at implementing this simple state management task using only routines and channels. Interesting. Let's see. In the previous example, we used explicit locking with mutexes to synchronize access to shared state across multiple routines. Another option is to use the built-in synchronization features of routines and channels to achieve the same result. This channel-based approach aligns with Go's ideas of sharing memory by communicating and having each piece of data owned by exactly one routine. Okay. Okay. So is it like can always be used instead of mutexes? Have I missed something? Access shared across multiple coordinates and other options to build and supply channel achieve the same result as channel-based approach. The same result. Yeah. So I assume you can always replace it. Okay, but it can be less ergonomic, right? Maybe that's a problem. In this example, our state will be owned by a single routine. This will guarantee that the data is never corrupted with concurrent access. Okay, in order to read or write that state, other routines will send messages to the owning routine. Yeah, I see, but it's so complicated. Other routines will send messages to the owning routine and receive corresponding replies. These read-op and write-op structs encapsulate those requests and a way for the owning routine to respond. Wow. Read operation. Key. Response with channel. Wow. Write-op key. Value. Response. As before, we'll count how many operations we perform. The reads and writes channels will be used by other routines to issue read and write requests respectively. So it's just a single channel. Why? Okay, reads, writes. Okay, here is a routine that owns a state, which is a map as in the previous example, but now private to the stateful routine. Stateful routine. Ah, okay, so only this routine has it, yeah. This routine repeatedly selects on the reads and writes channels responding to requests as they arrive. Actually, it's not as complicated as I thought it would be. I would say it's pretty neat. A response is executed by first performing the requested operation and then sending a value on the responded channel resp to indicate success. And the desired value is the case of reads. So we have map with key int and value int, loop, select. We are reading, and then if we read, we are setting a response with the value. If we write, interesting, but why would it work? Because of select, because it executes only one scene, so it guarantees that select not gonna trigger again at least how do I say that? Unless the scope has closed, right? Yeah, and then we write, and to respond, we send true. Interesting. So we're launching 100 routines. In each we are making a loop where we creating a read operation request with a random number, key random number from 0 to 5. Respond channel int. Damn, it's actually like when you imagine it, it seems pretty easy, but it grows so fast. you have to keep in mind so many scenes. read response. Okay, so we send in request to reads, and then we are waiting for response. Atomic at uint64 with ops 1. So we're counting how many have we done. Time sleep. Yeah, and we're just simulating in the mending task. Right? Or is it just... Okay, whatever. And write. We have only 10 writes. Random value. Channel. We are writing 2 writes. Waiting, blocking on response. And counting. Yep. Then we time sleep. Let everything to execute, right? We start 100 routines to issue reads to the state owning routine via the read channel. Each read requires constructing a read op, sending it over the read channel, and then receiving the result over the provided refs channel, right? We start 10 writes as well using similar approach, right? As the routines works for a second. Finally capture and report the OP counts. So we are loading read OPs and write OPs and just logging them out. That's nice. Running our program shows that routine based state management example completes about 80,000 total operations. Wait, but how? Wait, we're doing it only 100 times, isn't it? Am I missing something? That's a loop. Oh yeah, it don't stop, right? It keeps working, but we just checking the state in this current after 1 second. About 8,000 total operations, yeah. For this particular case, the routine-based approach was a bit more involved than the mutex-based one. Yeah, absolutely. It might be useful in certain cases though. For example, where you have other channels involved or when managing multiple such mutexes would be error-prone. Okay, you should use whichever approach feels most natural, especially with respect to understanding the correctness of your program. Okay. Sorting. Yeah, and that's the end. Panic, yeah. Okay, nice. So let's try. I want to go quick through this to check if I missed something. Mutex, web crawler. Okay. I'll have web crawler here. So your task is to change the code to limit crawler to at most 1 page per second while maintaining concurrency. In other words, crawler must be called concurrently. So it's a ticker, right? So we are calling crawler concurrently. Can we just where's crawl? Okay, crawl calls itself. Interesting. So we're calling crawl depth4. Crawl uses fetcher from the mockfetcher.go file to imitate a real crawler. It crawls until the maximum depth is reached, so it basically like imitates getting all the URLs from the page until you reach for page's depth, right? Okay, so what I wanna do? I'm creating a new ticker. Time ticker. Is it how I do it? Okay, I wanna I wanna go back and check it one more time. Ticker. Oh, I see it. Time, new ticker. New ticker. And it's like time.second. Define not used, okay. Once again, your task is to change the most one page per second while maintaining concurrency. Why is it 3 lines? Can I make it by 2? This one is confusing a lot. Like, I'm just calling it, and then I'm just waiting for ticker. .c. C is for channel, right? Oh, I need to stop it after that. Ticker.stop. Okay, how do I test it? CD go. Oh, I need fish. Fish. CD. CD 0. Go test. What the hell is it doing? Exit. Fail. There exist two crawls that were executed less than 1 second apart. So you want me to make it this way. Fail. There exist two crawls that were executed less than 1 second apart. Okay. Two crawls that execute 1 second. Is it because of ticker stop? Let's remove it, just to check it out. If F0 return. There exists a crowd that, yeah, still the problem. Now, why would it happen? We are calling crawl. We are launching indicators that it's done on the end of the scope. If depth less than 0, we are exiting it immediately. So it's gonna decrease the depth every time. We are fetching. If error is not nil, we are printing it, right? Can I just run it? Go, run, may not go. And I find finisher. 27, 21. But it's like right here, isn't it? Interesting. Fetcher. It's a global variable. It should be accessible. Okay, once again. Ticker. Time. Oops. Time new ticker. Time.second. Then we're waiting for ticker channel. Okay, go run main go. Undefined fetcher. Fetcher is global. How it tests it if it can't even compile? Main. But what? Fetcher. Fetcher.fetch. Mock fetcher. Fetch, yeah. Okay, let's test again. Fetch signal is this. What is it? Don't fetch signal. Okay, time Unix 00. So it's just basically this date. It's so interesting. Fetch signal. Don't edit this part, okay. Don't worry. Given a crowd modified concurrently hit, this exercise can be solved in several. You can do it rate limiting. Yeah, I read that. Time tick. Yeah. Wait a minute. Client is an interface that calls payload. Throttle time tick. Wait a minute. What? Am I missing something? New ticker. Tick. Tick is a convenience wrapper for new ticker. Provide access to the ticking channel only, unlike new ticker. Tick will return nil if the less equal than 0. Before 1.23, the documentation warns that the underlying ticker would never be recovered by the garbage collector, and that if efficiency was a concern, code should use new ticker instead and call ticker stop when the ticker is no longer needed. As of Go 1.23, the garbage collector can recover unreferenced tickers even if they haven't been stopped. This stop method is no longer necessary to have the garbage collector. There is no longer any reason to prefer new ticker when tick will do. Okay. Good to know. But it will not change anything, right? Undefined feature. Okay. Let me just go run test. Is it different? Go test? Just yeah, there's just go test. And where is found? I see not found, but where is found? Found. Not found. Found. Oh, here it is. Okay. Why it doesn't work? Okay, I'll just let him figure out what I want. Let's see. Okay, it swings for way too long. Okay, it wants me to wait before the range, right? Wait, but yeah, that's my bad. So it, but I should pass tickers then, isn't it? It's gonna create way too many tickers. It should be in main. And then create everyone there. The issue lies when how time tick is created and used. A new ticker is created inside the crawl function specifically within the for loop that iterates over the found URLs. Yeah. Independence. This means each running instance of the crawl function, each routine, and even each iteration of the for loop, the single crawl routine gets its own independent ticker. Yeah. These tickers know nothing about each other. Yeah. Okay, I understand. What you need the goal? It needs a single central gatekeeper outside in the main function. That all workers must check with before they start the main task fetching. This gatekeeper only lets one worker pass through every second. Can I? But it wants me. You can achieve this by adding 3 lines. So it don't want me to edit. Or is it? Oh, probably that counts. The channel. I'm back. Chan. Can't use ticker variable of type channel. Time. Okay. Okay. And now we need to wait for ticker. One page per second. Okay, I guess we can do it just right here. Ticker. It seems to work. 1 second each. Nice, let's go. Let's go, but how can I solve it in less than 3 lines? Okay, I solved it. But how can I do... how can I get the same result changing only 3 lines? Whoa. it doesn't have the original task, but I guess it will figure out by itself. I hope. Global rate limiter. Are there answers? I'm curious. Do I have it here? Yeah. Or is it? No, it's not. Issues. How to measure the test duration test time. Contribute. Okay. Are there like answers? Okay, I guess there is no there are no answers, and I'll just keep it. It works, then it works. I guess it's pretty good solution. Given is a producer-consumer scenario where a producer reads in tweets from a mock stream and consumer is processing the data. Okay. Your task is to change the code so that the producer as well as the consumer can run concurrently. Okay. Mock stream. Producer, consumer. Okay, where do I begin? I should probably begin with main. Where start time now. Stream get mock stream. Okay, tweets, producer stream, consumer, time since start. Okay. So consumer, now producer. Basically a loop where we're getting tweets from stream. It's probably timed there, right? Yeah, sleep. If error, end of file, return tweets. Okay, tweets append. Tweets append. Interesting. So I basically can just make an anonymous function right here, right? Anonymous go routine. Yeah, but it will return from this function, not from this one, which is interesting. I can use labels, right? There is no reason to use it because it defined here, it will return by itself. I'm just using label, outer, Label outer defined and not used. Yeah, and now I'm just outer. So you should do it other way. How do you return label? Golang return label. Exit label. Label breaks and go. Oh, it breaks it, not break. Okay, where is the break loop? Okay. So it can't return breaks. Okay, it doesn't matter actually. Break, outer. It should work anyway. What do you mean? Invalid break, label outer. Because it's not capitalized? No, it's not. What the hell? Invalid break label outer. Label outer declared and not used. Interesting. Is it because it's in a Go routine? Oh, actually that could be the reason. That must be the reason. Okay, let's start fresh new. Okay, I'll take some water and return. Okay, we are using a loop for that. Is it what we really want? So next is a scene which demands a lot of resources. I probably need a channel. Tweet, make, chan. Oh, it's a string? Okay, it's a tweet. What's your problem? Declare it and not used. Oh, because it's... It is the way I want to do it. Okay, let's just try. Okay, it's... I see. I can do that. But whatever, I can do it the other way. Tweet ch make chan pointer to tweet. And now what we're doing is taking and just sending it there. Tweet. And then we close channel. And then we are wrapping it in a routine. Expression go must be... yeah. But don't we need... Oh, we have a consumer there. But consumer takes just the array. Let's read again. Given is a producer-consumer scenario where a producer reads in tweets from a mock stream and the consumer is processing the data. It asks you to change the code so that the producers for the consumer can run concurrently. It's talking about Go. Does tweet about Golang. I would return channel instead of slice. Tweet. Tweets. It's a channel where we can only write. Channel. What if it's gonna close earlier than we receive everything? It's so weird to reason about. I don't need this anymore. Do I want to make it buffered? Will it solve it? Probably not. Probably not. T. This one looks good. Consumer tweet. Yeah, this one doesn't. Oh, I see a problem here. Yeah. It should be here on the read. But I don't care, I'll just use it from outer scope. Using for. But is it a good idea? It's probably not. Producer. Okay, I need to figure out how can I... If it's a producer, there should be several producers, isn't it? It would like make general sense. I can just create any amount of them. Or can I? I can make it recursive, but... Is it what I want? Okay, if I'm removing this loop, removing this function, if I'll pass channel right inside of it. Okay, I want to check tests. Are there tests? There is no tests. Time, okay. I just doing time. I feel insecure closing channel. I feel like I can just block out the other routines. Quantuma Ulpaca? Thank you for following. I appreciate it. Sorry for reading your nickname incorrectly. Oops. Yes, so what have I been doing? Yeah, I need to figure out how can I make producer concurrent. I can just move channel to the main function and then pass it in and then make it recursive, so it's gonna call itself several times until we reach the end and then close. But what if we close way too soon? Is it possible? Delay is always constant, so probably not. Okay, let's try. So what we're doing here, we're doing it like that. Make. And we are running producer concurrently. The same as consumer. Yeah, and we need to pass tweets inside. Tweets, chan, pointer to tweet. So this way we're also passing it here. Right. Makes sense, I guess. Now, tweets. Okay, so we are getting tweet, we are sending it. We are checking if we should close a channel, and if so, we probably return. And if it's not, if we not return, so we what we're doing? Yeah, we are calling producer recursively. Stream tweets. So let's check it. Okay, I'm in the wrong directory. Go run main.go. Undefined string tweet. What? Why can't it? Oh. Is the same? Oh, because it's no, it's package main. It should work. Here's stream. Maybe because go mode init. Tweets. Go run main. No, it doesn't work. That's weird. Why is it semi-transparent? Am I missing something? Here's stream. It's capitalized, so it's obviously global. And it don't need to be global, it's the same package. And it can see it here. There's obviously something wrong with my compiler. Oh, okay, yeah. Let's go. It's the latest go. Go mode. Go mode tidy. Am I missing something? The task is manifest so the producer and consumer can run concurrently to increase the throughput of this program, yeah. Why can I run it? That's so weird. Undefined. Okay, honestly, I just absolutely don't care, and I'll just copy it. Like, who cares? Right? I'll just make it that way. Redeclared. Yeah. It doesn't... There is no GoFMT, right? I don't have GoFMT. That's weird. 55 microseconds? It seems so wrong. There's obviously something wrong. I don't wait until it closes, right? That should be the problem. Because I close channel, right? But I don't wait for it to be closed. How can I do that? I need another channel done, right? Or do I? No, it just will... This... On closing this channel, this routine will just exit, which I want. And now I just need to wait for this routine here somehow. Will it work? Yeah, it does work, right? Does it? I have... Wait, what? Why I have 300 milliseconds longer? Let's reset it. Okay, I want to copy it first. Yeah, let's see. Okay, we're doing the same here. It won't run, obviously. I wonder why it can just get it from here. What exactly is wrong here? Okay, see. Okay, so it's in fact faster. But here I have exactly the same number, and here I don't. Maybe it's the first delay, right? I probably should start immediately, but I don't. Do I wait somewhere? I'm making stream and sending it. Or should I just immediately make another routine? No, I should read. Yeah, no, it will wait for it, right? Anyway. That's not the problem. Whoa. What have I done? Oh, because the return is here. Yeah, that makes sense. Okay, I want to read how mock stream works. So here is 300 milliseconds that I can get. It's like exactly 300 milliseconds. 330. It's talking about Go. Okay, so the problem here, isn't it? Oh no, it also can be here. This one should not be concurrent. I would guess. Because it's faster than this one. There's no reason for it to be concurrent. But let's try. Let's just... Oops. What am I doing? Okay. Doesn't tweet about Golang. But it changed nothing. It's stupid. Okay, it does change something, but it's not what I want. Oh, okay, I see. Yep. That's hard. Where do I lose 300 milliseconds? I wanna check it. I can increase this one. But we'll see. It's talking about Go is also should be also concurrent. That's a problem. Yes, that's a problem. So yeah. It's talking about Go. Go routine, right here. It should work. Let's go. Let's fucking go. We did it. I did it faster? No way. I'm a cheater. It feels so good. Okay, I finally get it. So it's talking about Go, just takes time too. I wonder if I can remove this one and just make it here. If I'll wrap it in a Go routine and we'll just call it regularly, it should work, right? And it's gonna be neat. It's gonna be cleaner. Something like that. Okay, don't break, please, don't break, don't break. It works. Yay, let's go. So much better now. So good. Let's go, next exercise. So, race in cache. Given some code to cache key values pairs from a database into the main memory to reduce access time. Yeah. Note that Golang's map are not entirely thread safe. Multiple readers are fine, but multiple writers are not. Change the code to make this thread safe. Okay, so it basically wants me to add some mutexes. Right? Check test, mockdb, mock server. Don't tell me it will not see these packages again. I will go crazy. Okay, cache size 100. Key store cache loader load string. Okay. Page key volume. Okay. Key store cache string list element. Container list. What is? I have no idea what. Element is element of linked list. Oh, okay, I see. I guess. Why would you want it? But okay. Pages. Cache, pages, list. Oh, I see. I guess I see. Load. Func, yeah. Okay, it's... I'm not ready for such level of abstractions. So new. They just return instruct with load set to load. Okay, I see, but so it's passed in. And cache is just a new map, right? Get. Okay, I guess this is a method we will work with. It's highly probable. Loader, okay. Load. Okay. Run. Okay, so we are doing get. What we need? We have a map here, so we also need mutex. What is it? Is sync, right? Mutex. It's unused, yeah, right? Now I want get to run concurrently, or is it how it works already? Go. Yeah, it works concurrently already. Mutex lock. Oh, my bad. It's passed by pointer, which is good. Now k.mu.lock and defer. Oh, because it's map. We can read it. It's not mutex. It's RB mutex, right? So we can. So we lock only on read, not on only on write, not on the read. Okay, but how I never done this before. Write lock, right? Oh, it's get. And where is set? Am I missing something? Gets a key from cache. Loads it from the source if needed. Yeah. Miss. Load from the database and save it to cache. If cache is full, remove the least used item. That's interesting. So I guess it's not gonna be as obvious as I thought at first. Why can I lock but I can write lock? Am I missing something? Try lock. Lock, lock, yeah, unlock. There is no RV mutex. Weird. But whatever. Okay, we are within, it's okay. It's really safe, I would assume. Keep pages move to front. What is A? List element. Okay. So we are getting key from the cache, and if it's okay, if we can get it, we're just key pages move to front. What does move to front? Moves element E to the front of list L. If E is not element of L, the list is not modified. The element must not be nil. But what the point? Okay, whatever. Return a value, page value. Okay, makes sense. Miss. Yeah, if there is no data in cache, load from the database. Load from the database and save it in cache. Yep. P page. If cache is full, remove the least used item. Oh, so it's basically like a rating table and the most used just moves to front. Makes sense, I guess. What does keyload key? Should it already be like... No, it should not. It's okay. I don't need to make it... to wrap it in mutex. If cache is full, remove the least used item. Right. Cache size and key pages back. Remove from app. Yeah. Remove from list. Okay, how do I check? Given is some code to cache key values pairs. Mock database. Yeah. Also try to get your solution down to less than 30 seconds to run test. Can fetching from the database take the longest. Map access is unsafe only when updates are occurring. As long as algorithms are only reading and not changing the map, it is safe to access the map concurrently without synchronization. Okay. If possible, get your solution down to less than 5 seconds for all tests. Oh. Background reading. I guess I'll need those. Test your solution. Go. Okay, I need another directory. cd to racing. Oh, oops. cd to go run. Okay, go test race. Oh, it takes a lot. Fail. Doesn't fit. Well, what the hell? Damn. So what's the problem? Why it fails? Go run, may not go. And the fight mockdb. I'm so tired of that. Okay, 1 and 2. Okay, it crashes. But why? Sleep. Is it? If it would be a deadlock, it would tell me, right? If it was. Unmock server funk 1 routine 28. Cache get test and number. I can get. Is it me who does something wrong? Because I would assume it should. Okay, let's read again. Given is some code to cache key value pairs from the database into the main memory to reduce access time. Right. Note that Golang maps are not entirely thread safe. Right. Multiple reads are fine, but multiple writes are not. Change the code to make this thread safe. So it's not thread safe. So that's the problem. Okay, here is read and here is write. And what can I do? I can just add mutex, right? I already have it. K mu lock K mu unlock. Segmentation violation? No way. Invalid memory address or nil pointer to the reference. Okay, because it was... I need to read about every mutex. How do I use it? So every mutex is read-write a mutual exclusion lock. The lock can be held by an arbitrary number of readers or single writer. Okay, makes sense, right? The zero value for every mutex is an unlocked mutex. Okay, a mutex must not be copied after first use. If any routine calls mutex lock while the lock is already held by one or more readers, concurrent calls to a lock will block until the writer has acquired and released the lock. Okay, I need to read it one more time. If any routine calls lock while the lock is already held by one or more readers, concurrent calls to lock will block until the writer has acquired and released the lock. But what is lock? How do I know? To ensure that the lock eventually becomes available to the writer. Note that this prohibits recursive read locking. A lock cannot be upgraded into a lock, nor can lock be downgraded into a lock. So basically, lock is a write lock, right? And lock is a read lock. The terminology... Okay, lock locks everything. And lock, I guess, allows to read. That would make sense. But just naming is just ridiculous. Okay, let's try it again. Lock. Unlock. There is concurrency. Oh, it's outside of it, yeah. Okay, at least it works. I mean, it doesn't, but... Get? Go test trace. Will it give me something more useful? It's so weird. Okay, give me a second. Okay, let's read through methods. Lock locks RV for writing. If the lock is already locked for reading or writing, locks until the lock is available. Lock locks RV for reading. Should not be used for recursive read locking. A blocked lock called excludes new readers from acquiring the lock. Caesar. Okay, that's the point where I'm breaking apart. but we'll figure it out. Let's see this. So go routine sleep. Load. Page. What's the problem with that? So we're going in deep, right? It's load. Okay, load. db get. Time sleep. What's wrong? There is probably something so wrong about my compiler, I would guess. Let me reinstall it quickly. How can I do it? I can open recent Nix. I'll just remove it from here and install it via brew. Fish, Darwin, boot switch flake. Okay, password. Whoa. Failed. Why is that? Because it's Golang and not Go? Really? It's Go, but okay, I'll just try. No cask with this name exists? It's so weird. I can literally see it on my screen. Why can installing Go warning because Go is unavailable. Okay, let's try another way. How do I do that? One 0.24. Why it works this way? It's ridiculous. version. Nice. Let's switch back. Go. Fish clear. Git stash. Git. Oh, okay. cd go. Git stash. Git pull rebase. Nick star. Okay, never mind. Not safe. Okay, now it should work, right? Right. Git. What I'm doing by git? Cd to go run minus go. That's ridiculous. And the fight mockdb. Go test. Honestly, I think I'm done for today. I'll need to figure out what exactly am I doing wrong, why it breaks when it shouldn't. Yeah. How to end the stream?